Hello, welcome to our first video in using and how to do Gaussian elimination. Okay, so if you have not subscribed to my channel yet, kindly subscribe for more videos in the future. Alright, so Gaussian elimination, how do we do it? Okay, so if I have a matrix and I want to perform Gaussian elimination on it, then my main motive is to reduce the matrix to this form. Okay, A11, A12, A13, 0, A22, A23, 0, 0, A33. Okay, in other words, I want to create some upper triangular matrix from this matrix. Okay, and this method that you use to do is what we call row reduce echelon form. Okay, so you are reducing the subsequent elements under each leading coefficient or each leading element in each row. Okay, so now from this that we want to do, it means that in this matrix A given here under A11, you have to make sure that the down elements are 0. Then you come to A22, the down 2 should be 0 for a 3 by 3 matrix. If it was to be a 4 by 4 matrix, then you have to continue. Okay, now with this idea here, how you'll be able to perform this is that one, rules that are accepted here is you can swap rows. Okay, row swapping. You can swap columns as well. Okay, but you are not there yet. Column swap. Okay, you can multiply a scalar by a row. Okay, and you can add 2 rows, okay, to reduce 1 row. You can swap row like that. You can subtract as well. You can multiply scalar. That is how it goes about. Okay, now with all these ideas, one thing I would advise is that always make sure that your A11, that is your leading row, is starting with an element of 1, so that each reduction becomes easily. Okay, so looking at this whole matrix here, the second row has an entry starting with 1. Okay, so one thing that you can do is that we swap row 1 and row 2. By swapping it, we write it symbolically as this: row 1 and row 2 being swapped like that. It means they will be swapped. Okay, so now we'll get a new matrix that will give us what? 1, 2, 3, meaning row 2 is becoming row 1, row 1 is becoming row 2. Then you get -2, 2, 3. Okay, sorry, -2, 1 rather. Okay, -2, 1, -1. Okay, alright, then you get 3, 0, 1. Okay, now with this, what you do is that looking at the down elements under the first entry, which is 1, this entry. Okay, looking at the elements down, we have -2 and 3. So what can I do to -2? Looking at 1 and -2 to make sure that -2 becomes 0. You see that I multiply 1 by 2 and add it to -2. Okay, so one thing we can do is that we multiply, so 2 row 2 plus, sorry, 2 row 1 rather. Okay, you have to multiply row 1 by 2. Okay, then we add it to row 2. Then this will give us a new row 2, whereby in that case the first elements will be added and then we'll get row 2 to be 0, starting from 0. Okay, now the difference between row 1 and row 3 is what? 3. Okay, then you have to multiply row 1 by 3, then you subtract row 3 from it. Okay, look at these are the elements that we use. What can I do between this and this so that I'll make this side, okay, 0? Just have to multiply row 1 by what? 3, then subtract row 3 from it. Okay, now we'll get a new matrix from these conditions written to be write our row 1. We didn't change our row 1. Okay, so we had the same thing. Now row 2, we are saying that it is equal to what? 2 row 1 plus row 2, the original row 2. So here 2 times row 1 plus row 2, 2 times row 1 will give me what? 2 times 1, which is 2, 2 times 2, which is 4, 2 times 3, which is 6. Now I add it to row 2, to get my new root 2, and I'll get negative 2 plus this one, negative 1. So if I add them, I'll get 0, okay, 5, 5, okay. Then I come and write this will be my new root 2, okay. So I get 0, 5, 5. You want to make sure that the down part of 1 is 0. That's why we did that. Now 3 row 1 will give me what? 3 times 1, 3, 3, 2, 6, 3, 3, 9. Now I have to subtract row 3 from it, okay. Now if I subtract, I'll get 0, 6, then what? 9 minus 1 is what? 8, okay. So I get 0, 6, 8. This is very simple, right? So now it means we've accomplished this task, this side. It is left with this part to be 0. It means I have to make sure that this is also 0, okay. So employing the same idea, we can say that you divide root 2 by 5. I mean, I want to make sure that the 5 becomes 1 because I have 5 here and 5 here, okay. So if I divide by 5, it will be very easier. That's why we said that you can multiply a row by a scalar. In other words, the same as 1 over 5 times root 2, okay. This will give me a new root 2, and now we'll get something like this: 1, 2, 3, 0, 1, 1, okay, 0, 6, 8. Okay, now in reducing this, I can say 6 times root 2 rather, okay. So 6 root 2, okay, minus root 3, and this should give me a new root 3, meaning if I do that, this side will be 0, okay. So I'll get a new matrix to be 1, 2, 3, then 0, 1, 1. Always you write your pivoting row, that is the row that you are standing on to reduce it down becomes your pivoting row. Now I have here to be 0 because 6 times 0 here, okay, minus 0 will give me 0, okay. Now 6 times 1 minus 6, okay, so I'll get 0. 6 times 1 minus 8, I'll get what? Negative 2, okay. Now looking at row 3, there is only negative 2 present, so I can divide the whole of row 3 by what? Negative 2, okay, so that I'll get 1. I want to make sure that all my leading diagonals becomes 1, okay. So actually you can maintain it like this, but then for simplification's sake, let's divide with 3 divided by negative 2, and this will give us a new row 3, and then the whole matrix will tend to be 1, 2, 3, okay, 0, 1, 1, 0, 0, 1. Okay, so this is the reduction form of our matrix, giving us negative 2. If you remember, it was negative 2, and I think 1, 2, 3. I have 3, 0, 1 here. I've forgotten the one that was here, so let me go and check it up and bring it, okay. Here was 1, negative 1, okay. So this matrix has been reduced to this form, okay. So this is what we call row reduce echelon form, or Gaussian elimination, okay, any way you want to call it, okay. So in our next video, I'll show you how to use this method to solve for a systems of linear equation. In fact, this is the best way of solving linear equation. Other than that, there are some linear equations that has finally many solutions, okay. So we'll be doing videos on how to use this to solve systems of linear equation, and also how to use this to find your eigenvalues and eigenvectors, okay. Thank you, and don't forget to subscribe to my channel. See you next time.